Hey everyone, welcome to another episode of Curious Talks. Today we are talking with Kshitij Khandelwal, the CTO and co-founder of Pixxel. Pixxel is a satellite imagery startup which aims to provide better data and analysis to help crops grow and solve problems like climate change and pollution. We had an interesting talk regarding space tech startups, satellite imagery, and a lot of other interesting things. And I hope you will enjoy this podcast. Let's just start with what is Pixxel and why did you decide to make it for the audience to give some context.
Sure. So, Pixxel is an Earth observation company. The idea behind Pixxel is that there are sources of satellite imagery right now that people use for a whole host of activities. But when you look at some of the world's biggest problems and challenges, especially the ones with agriculture, when you're looking at challenges in environment conservation, a whole bunch of things you cannot do because you just cannot see a lot of issues, and that's a fundamental problem with just the satellite data that is available. And what Pixxel does is Pixxel builds hyperspectral satellites. So, uh, so basically, with hyperspectral satellites, you can look at a whole lot of things that you cannot with your typical red, green, blue data. So for Avest and I, when we started looking at satellite imagery, we realized that there is a lot of value in this hyperspectral imagery, and that is why we decided to do it.
So you mentioned hyperspectral imaging. So how does it work?
So if you look at RGB, you've got three, how do I put it, three wavelengths that you're looking at. So you get your imagery in three bands, just like what you take from your phone, right? When you look at any panchromatic image, it's an image in a single band. When you're looking at a multispectral image, sometimes you add the infrared bands and a bunch of other data. With hyperspectral, what you do is you take really, really narrow bands of imagery. And the idea with that is there are these hundreds of bands, and each of them represents a certain part of the EM spectrum. And from basic spectroscopy, we know that when you look at any chemical, you can see that it has a certain absorption spectrum. And the idea behind hyperspectral is that you can identify chemical properties of things like soil. You can identify pigments like chlorophyll in plants. You can use that for a whole lot of analysis, just because you have these narrow bands that allow you to identify the chemical signatures. So that's basically what you're trying to do.
So how does that came across this thing called thermal imagery? Is it really similar to hyperspectral in any sense? Because
So
there are other startups doing something similar like this, like Albedo is there and all.
see, there's a bunch of things. Different types of imaging. There is active imaging and there is passive imaging. When you look at synthetic aperture radar, that's LiDAR. That's a kind of active remote sensing. LiDAR people don't do from space because of the attenuation. But if you look at passive imaging, the image that you take with your phone is a passive image. So when you turn on your flash and you're getting a reflection, that sort of becomes an active image. What we do with hyperspectral is we primarily dabble in the visible range of the electromagnetic spectrum and some part of the infrared range. However, when you go further down into the infrared range, it becomes more and more difficult to capture the signal. And that is where your thermal imaging comes in. So there are companies like Albedo now who want to do thermal imaging. And it may be active, it may be passive, but that range goes up high. It's a little more difficult to do. Resolution is something that also becomes a problem as you go, with sensors that are built for wavelengths like larger wavelengths, basically. So thermal imaging is a is a subset of hyperspectral imaging, you can say in some way. You can do hyperspectral imaging in any range. You can do hyperspectral with SAR as well. The point of hyperspectral is there are more than one spectral bands. But for like just to give an idea of what Pixxel does versus what someone like Albedo or any thermal imaging company is trying to do, it's different. So yeah, we don't do thermal imaging, and our hyperspectral imaging does not incorporate thermal.
What is the ideal scenario for Pixels? Like if by mid 23, as promised, your 30 satellites get deployed, which is our ideal scenario. How do you think? Like how would it
Uh-huh.
impact the world?
The thing, there is a need for this data, right? The data is not already there. So there are multiple things that you can do with this data if it is available. And there are issues that we currently see, like forest fire. We are unable to detect climate change in a lot of places simply because we don't have the right kind of data. With agriculture, we are looking at a growing population and food scarcity. So, as we move ahead, making sure that our agriculture processes are more efficient, making sure that a whole lot of the work that we are doing in terms of our pest infestation detection, that becomes more efficient. Those are some of the things that we want to impact. As we move ahead and add more data sources to our arsenal, we do want to look at pollution monitoring as well, very seriously. So these are a few things where we believe that we can create real world impact.
Okay, we're planning to deploy about 30 satellites or 60 satellites in the network. So how do you think would you combat the problem of space debris and crash?
Here's the deal. Space debris is definitely going to be a big issue as we move ahead. However, when you look at Earth observation constellations, these are 15, 20, 25 satellite constellations with a lifetime of 4 to 5 years that come down, fairly quickly. If you're comparing that with 10,000 ComSats that someone like OneWeb, SpaceX, and all those folks want to launch, that fades away in comparison. But to take responsibility, we have propulsion systems on our satellites, and we actively put it into safe orbits for to bring them down, basically to get them down to Earth. And as soon as the mission life is complete, we decommission these satellites. So we don't make sure that they linger. Space debris is something that creates a big issue if you are as high as 700 kilometers, 800 kilometers, and you're taking 20, 25 years to come down. That is when it starts becoming a problem. But for us at 550 kilometers, it's a fairly quick descent to Earth as soon as propulsion stops.
And how long? Okay, you mentioned about a mission life. Like, how long is a Pixxel satellite's mission life? Like, as of now?
So the technology demonstrator satellites go for a couple years each, and the constellation satellites are built for a 5-year life.
There are a lot of other companies who are entering of space tech companies coming up. Do you see this as a new space race, like how USA and Russia had during the Cold War period? Do you see that this as a private version of that?
Bunch of companies doing good work in the industry, and when you start looking at it, there's a lot of private capital being deployed in the space industry as well. You did not have these multi-billionaires come and run space companies or fund space companies of their own. So definitely you see something akin to a space race that is coming up. However, I would still say that there is a certain feasibility check that needs to happen. So there is obviously a lot of goal setting that's happening there, but we need a feasibility check as to how will we create a better space economy? How will we basically bring the benefits of space back to Earth, as well as exploit them in space itself? So those are a few things where we definitely need a lot of work, and that's when the gold rush of space will start. So space race in the 60s was a very mindless exercise. A lot of money was being thrown around it. And what happened because of that was that public perception towards space kind of went downhill. The amount of funding that NASA received drastically went down as well during the Nixon era. So yes, there is something similar to that coming up. But again, if I look at it from Pixxel's perspective, our priority is currently just making sure that we build a self-sustaining company.
Yeah, that's fun. And also, like you said talked about self-sustaining, right? That's going to come to it. How did you convince investors of doing something crazy like this? Like, not exactly crazy, but like monetarily crazy, because there are a lot of people who would say that this is not possible or throw it out of the window.
Yeah. So here's the thing: the way we reached out to investors was kind of not the best way in the beginning. We reached out to some institutional funds. They strung us along for quite some time. They were building their space theses, or so to say. But then what we did was we reached out to a lot of college alumni admits, and a lot of them just put in small checks simply because they thought, what we were doing was interesting to them. Personally, I believe that any investor looks when they're looking at a business. And if there is no risk to the business is like someone else would already be doing it, right? So there is a technology risk, there is a team risk, there is a market risk. So technology risk, can the company build this technology? Team, can the team do it? Then there is market, does a market exist for it? There is a certain amount of regulatory risk also associated with it. Is the regulation right? And then there is obviously competitor risk. Are there any competitors? So these are a few things that they look for, and we were able to satisfactorily have answers for a lot of those questions, which is why some of those things went well. But it was a lot of struggle for us to raise money in the beginning, back in 2019, 2020. But now, we are in a significantly better position in comparison.
Also, recently, there was this Bharat interview you guys gave. One more thing which was very interesting in that was that you mentioned about exploring the asteroid belt and designing tech in like a few years down the line. What do you think about that? And like, do you see how is it possible and why no one has done it yet? Because it's obviously crazy efficient if you can pull it off.
Yeah, so two good questions. One, how is it possible? It's kind of a shame that we have had a man on moon. We have had many men on moon, but we are yet to explore the Earth's crust beyond some 10 kilometers. So there's a whole bunch of things that we definitely need to do over the coming 2 decades in terms of building out technology. And as we move ahead, we are messing up with the resources on Earth. There's going to be a lot of toxic waste that will be thrown around just because we are digging so deep. We are extracting resources at such a high pace, like never before. Climate change is not a natural phenomena, right? So this is something that we've brought upon this planet, and as we look at it over the next couple of decades, temperatures are going to get higher, climate cycles are going to get more and more disturbed, and that impacts a lot of things. To start with, agriculture all over the world is going to be significantly impacted. You're seeing snow in Texas like never before. So there are these things that you are currently seeing, which are caused by issues here that we are creating. And a very safe way to tackle these issues is some of the rare earth minerals that we need, and we need in very high demand, stuff like indium, right? Or things that you need for your electronics, things that you need to build out some of the very essential things here on Earth, as well as medicinal compounds. So for all of those things, it's at some point of time, there's going to be a graph between the feasibility of getting stuff from space, because that's expensive, and feasibility of extracting it here on Earth, and understanding the damage that it causes to our environment. So once we cross that barrier where we are creating more damage here than we can just go get it from space, as well as space technology matures, space transportation matures, robotics in space matures, we are looking at ways of extracting resources from space and using them on Earth. So this is where we feel that we want to be as a company. Pixxel was built with the goal of being at the forefront of space exploration in some way, and to do that, our way is to first build a self-sustaining company and then go into these more challenging problems as we move ahead. So I won't say that it's happening tomorrow. I would say that as we move ahead over the next decade, next couple decades, we would want to dabble into these activities. But again, that's a long shot right now. The priority is to start by making life here on Earth better with satellite imagery that can be used in these segments.
Some people were very skeptic about this technology just because they think, I don't know, due to Hollywood influence or something, that it's sort of a breach of privacy. So as you're a CTO, you would have a better idea of this. Is this more of a myth?
I mean, we spend so much money into making these satellites. Why would we want to look into your backyard, right? The way we are building our satellites at Pixxel, our goal is to optimize these for applications in agriculture, environment conservation, and a bunch of activities that may not necessarily violate privacy, except of oil and gas companies or people who are trying to create a lot of issues here on Earth. So, I mean, it's a silly question. How how do you impact privacy? I mean, what do you want us to do, right? With 5-meter imagery, what are we going to find out? So yeah, that's the idea. Unless you're looking at like centimeter level imagery, it doesn't really affect privacy. And when you start looking at that level, there are a lot of laws, right, associated with privacy. So there's a whole bunch of regulation that comes in as you go into sub-meter satellite imaging.
How these satellites are planned to launch? Like how long does this process take of planning it and then launching it?
Yeah, so I would say if you're starting from scratch, right, it's almost 12 to 14 months process. Unless you have pre-built designs that you want to manufacture according to and just adapt payloads to. It's longer for agencies, but from our experience, we do microsatellites. These are not CubeSats, but these are not large satellites either. So the idea is you start with conceptualization of any mission. You start with a mission concept review. You jump into creating system requirements, subsystem requirements, software requirements, a whole bunch of requirements. Once you have a consensus on the requirements, you get into a design phase. There are a couple of design reviews or 3, depending on what you choose. So there's preliminary design, there's a detailed design review, and a critical design review. Around critical design review, you sort of decide what kind of hardware do you want to fly. You decide if these are the vendors that you want to go with. This is the stuff that you want to manufacture in house. These are manufacturing partners that you want to look for, right? So of course, that communication process happens throughout the design phase, but towards critical design review, your configuration takes shape, and that's where you take a decision that this is going to be the satellite. This is how the satellite looks like. Post critical design review, you start with ordering prototyping components, doing unit level testing. Then you jump into trying out different sub assemblies inside the satellite. You get into a complete assembly of the satellite. There is hardware software integration, debugging. After which you look into things like system integration seriously. So you have a system integration review. Once that's done, you get into test readiness, you test the satellite rigorously, and then after that, you prepare for launch. So it definitely is a fairly long campaign, but it's just as fun. So you can skip a lot of these depending on, this also depends on how serious your mission is. So for a university mission, let's say, a lot of these things are not necessary. But for a commercial grade satellite, we need to take care of some of these things to ensure that there is reliability on the mission. So how do you get finalize these clients and all these vendors who are going to carry the payload? Or is this something like trade studies? Yeah, usually trade studies only. So we do different trade studies to understand, what is a certain vendor's area of expertise. What are some things that they have flown before? So we try to look at their space heritage. We try to look at the lead time of the product itself. We try to look at their mass manufacturing capability. Can they make it? Can they make a lot of it, or are they just a very small vendor? We also look at a whole host of other things like are there any regulatory export issues? If they're in India, we try to visit their facility and have a look at them. Then there's also cost. There's always cost. So I mean, these are some of the parameters that we use for trade studies. So these coupled with technical feasibility is how we decide a vendor. Does that make sense to you? Yeah, that makes sense. Like basically combining rate, the history and the safety regulations. If that's how you pretty much. Okay, man, that's great. Also, one more thing I had, how do you think the private companies have this advantage or are there disadvantage while doing these businesses? Is it different things? Yeah. So in the US, if you look at it, almost all space activities that private companies take up are very much in tandem with the government priorities. Whether it's the Department of Defense, whether if it's individual entities of the DoD like US Air Force, if you look at even NASA through their different labs, or you want to fly. You decide if these are the vendors that you want to go with. This is the stuff that you want to manufacture in house. These are manufacturing partners that you want to look for, right? Of course, that communication process happens throughout the design phase, but towards critical design review, your configuration takes shape, and that's where you take a decision that this is going to be the satellite. This is how the satellite looks like. Post critical design review, you start with ordering prototyping components, doing unit level testing. Then you jump into trying out different sub assemblies inside the satellite. You get into a complete assembly of the satellite. There is hardware software integration, debugging, after which you look into things like system integration seriously. So you have a system integration review. Once that's done, you get into test readiness, you test the satellite rigorously, and then after that, you prepare for launch. So it definitely is a fairly long campaign, but it's just as fun. So you can skip a lot of these depending on, this also depends on how serious your mission is. So for a university mission, let's say, a lot of these things are not necessary. But for a commercial grade satellite, we need to take care of some of these things to ensure that there is reliability on the mission.
So how do you finalize these clients and all these vendors who are going to carry the payload? Or is this something like
trade studies? Yeah, usually trade studies only. So we do different trade studies to understand, what is a certain vendor's area of expertise. What are some things that they have flown before? So we try to look at their space heritage. We try to look at the lead time of the product itself. We try to look at their mass manufacturing capability. Can they make it? Can they make a lot of it, or are they just a very small vendor? We also look at a whole host of other things like are there any regulatory export issues? If they're in India, we try to visit their facility and have a look at them. Then there's also cost. There's always cost. So these are some of the parameters that we use for trade studies. So these coupled with technical feasibility is how we decide a vendor. Does that make sense to you?
Yeah, that makes sense. Basically combining rate, the history, and the safety regulations. If that's how you.
Yeah, pretty much.
Okay, man, that's great. Also, one more thing I had. How do you think the private companies have this advantage, or are they at a disadvantage while doing these? Is it
different things? Yeah. So in the US, if you look at it, almost all space activities that private companies take up are very much in tandem with the government priorities. Whether it's the Department of Defense, whether if it's individual entities of the DoD like US Air Force, if you look at even NASA through their different labs or centers, they are constantly providing these projects to private companies, and they have a lot of projects for which they fund these companies to take up activities for them. So there's always this public-private partnership that happens, and then the venture capital ecosystem also enters, and it becomes a really healthy thing where they can use public funds for a lot of their work. If you look at SpaceX and the Dragon project, a lot of it was funded by NASA. So these public-private partnerships are what keep that ecosystem alive. Over here in India, we don't have a lot of that. So while private players have advantage in the way they can take risks, right? Because if it fails, people are not going to cry that public money is being used for failure, which is why you don't need to have 3 times triple redundancy or quadruple redundancy on a lot of components, let's say, or your design processes are not that long, simply because you don't have to worry that much about reliability. That is where private players have advantage in speed, but the scale is where government has a big advantage, where they can take up these activities at scale. There are a few companies, handful companies that do such activities at scale in the private sector. But I don't think it's really possible without a lot of government support as well.
Also, recently, India allowed the entrance of private companies into the space. Has that been of help for you guys?
Absolutely, yeah. So we've gotten testing facilities from URSC. They've been particularly helpful on radio licensing and a bunch of other things as well. So it's definitely of help, and we appreciate the kind of announcement that has come with the government of India. There needs to be like a lot of work needs to be done, but they are moving in the right direction. They were waiting on the space bill for quite some time, and now they have the first draft for the remote sensing policy. They have the first draft for the new COM policy. So it's improving, and it's improving pretty quickly, which is a very positive change to see.
Yeah.